Hello again. One more time here to talk about equations. Remember, an equation is two expressions set equal to one another, and it has an equal sign in it. Therefore, the goal of the equation is to get the variable by itself. In other words, you might hear me say every once in a while to isolate the variable. Now, to isolate the variable or get the variable by itself, we talk about the golden rule. And we say, what? Don't worry about that bell. You don't have to leave. You can just still sit where you are and record this and watch this and record what I'm doing here. So, what you do to one side means you must do to the other. Side. Got the side there, sorry. But I put it in there. So what you do to one side, you must do to the other. And that equal side is what the equal sign is what determines that. Again, if you need to, you just go ahead and draw that line down from the equal sign, and then that way you have that barrier. Okay, I got to go do something to this side, I got to do it to the other side. The steps for a two-step equation is to do this. First, undo. Remember, inverse, undo, addition or subtraction. Okay? In other words, if you remember, what we're really doing is we're making zeros. Okay? And what I mean by that is we're using the additive inverse or the opposites. Because as we said multiple times in this class, 0 is our identity element for addition. So adding 0 does not change anything. So we're making zeros technically. For step 2, we want to undo multiplication or division. And in this case, can anybody tell me what we are making? Oh, let me go ahead and do a different color while you're thinking about it. If you said ones, you are correct. You're making a 1, which is the multiplicative inverse. We're using the multiplicative inverse, I should say. Because again, when you multiply or divide by 1, nothing changes. So you want to make sure you do that. And then the big thing that I want you to highly remember and recommend doing all the time. When you're solving equations, extend page, hello, thank you. When you're solving equations, you can always check your answer. Remember, the point of this is you're getting the variable by itself. Therefore, if you substitute that variable back in, you want to make sure that the two expressions are equivalent to each other, or they equal each other, meaning that you solved the equation. So going to the next page, we're going to solve some, and also that nice tricky one. So 10x plus 2 equals 102. So I'm going to draw that line down. What you do to one side, you do to the other. I have multiplication of 10 and addition of 2. I want to get rid of that adding 2 first. That means I'm going to subtract 2. But if you notice, think of that as a positive 2. You want negative 2. What does that make? Positive 2, negative 2, that's 0. But what you do to one side, you got to do to the other. And I draw the results line. Now I have 10x equals 102 minus 2 is 100. Now I got to get rid of multiplication. What's the inverse of that? Division. So I divide both sides by 10, because what you do to one side, you got to do to the other. Now, what is 10 divided by 10? Truthfully, it is equal to 1. And 1 times x is just x. And then 100 divided by 10 is 10. So you get x equals 10. Now I'm going to verbally go through a check. 10 times 10, 100. 100 plus 2, 102. That does equal 102. And that's what it is. The second one, we're going to draw the line down. And notice that you got a -6. So subtract 6, -6, whatever you want to think of it as. And how do we get rid of that? We're going to add 6 because that's the opposite. And what we do to one side, got to do to the other. Draw my results line. I have x over 3 equals, and now we got to remember our rules. -9 plus 6. Signs are different, so we subtract and keep the sign of the bigger number. So we have bigger absolute value, that is. So we have x over 3 equals -3. Now how do we get rid of the dividing by 3? Oh, that's right, we multiply by 3. And I always like putting them to the side, not below like we did everything else. And that way you notice that there's a 3 up on top that goes to 1, there's a 3 on the bottom that goes to 1, and now we're just left with x. But on the other side we have -3 times 3, which is -9. Again, just a verbal check. -9 divided by 3, well, that'd be -3. -3 plus -6, that would be -9. It works. The next two, uh-oh, wait a minute, the variable is on the right. Oh no, don't worry. It doesn't matter where the variable is. You've got this line. And if you want to change them, you technically can. It's called the reflexive property of equality. It doesn't matter. But I'm going to leave it like this. So we have subtract 8 or -8. How do we get rid of that? Oh, that's right. We add 8. The opposite. What we do to one side, got to do to the other. Now, -48 plus 8. Signs are different. We subtract. Keep the sign of the greater absolute value. -8 plus 8, that's 0. I'm not even worried about writing down the zeros. Just know that we got 0 there. But we still have to write down a -5k. Oh yeah, don't forget that equal sign there too. I think I might have done that on the other ones. Oh no, I didn't. Never mind. All right, so we have that. But remember, it's a -5k. That's why we want to think of it as negative, even though that technically is in there as a subtraction. So how do we get rid of -5k? We got to divide by the exact same thing. That means we got to divide by -5. Why? Well, what's -5 divided by -5? That's right, 1. Not -1, +1. So that's why we can get k all by itself. And then -40 divided by -5 is 8. So plug 8 in. 5 times 8 is 40. -8 minus 40 becomes -8 plus -40. Add, keep the sign, you get -48, it checks. And then here's that tricky one. We can't get rid of that 9, but it's addition. You said to get rid of that first. Well, it doesn't hold true all the time, that's why I'm showing you. But if you notice on every single one, when I went and checked them, we multiply to divide first, then add or subtract. Why? Oh yeah, that's right, because of that thing called PEMDAS. Well, if you notice, the first thing to do on solving an equation was to get rid of addition and subtraction, then multiplication, division. So we're working what? Backwards. To solve, we're working backwards. So on this one, if I told you what x is, if I told you to put a number in for x, what would you do first? You would first add the 9, and then you would divide by 6. So what do we got to do? We got to work backwards. So what does that mean? We're going to get rid of dividing by 6 first. Now I'm going to erase this because of the fact that I want to draw it in there. But you could put it off to the side a little bit more. So how do we get rid of dividing by 6? The inverse of division is multiplication. And I'm going to multiply by 6 by doing it on the sides. So that way this 6 and this 6, they become 1s. So I have x plus 9 equals, if you want to draw that line down, go ahead. And then 3 times 6 is 18. Now we still got to isolate that variable. How do we get that 9 out of there? We subtract 9. Because a +9 and a -9 equals 0. And then we're left with x equals, and 18 minus 9 is 9. So let's try it, people. 9, plug it in here. 9 plus 9 is 18. What's 18 divided by 6? 3. That works. Therefore, that one's a little trickier, but you got to remember you're working backwards with that. I know this was a little longer, but it was a little bit more of a lesson, and we'll practice it in class. Have a good day.